Here's my next example. This is actually part 4, not part 3. And f of x equals 2x squared minus x minus 1 over x squared minus 1. And this function is actually very similar to what I did last time, but it's got some subtle differences here. It's still quadratic over quadratic. Okay, so you're definitely going to have another horizontal asymptote on this one as well. The problem with this one is you're going to have holes in this one, because when you factor this thing out, you're going to see that there's a common factor involved. So right here, if you factor the top, it factors to 2x times x, and it'd be plus 1 minus 1. I think that's right. Negative 2x plus 1x is negative 1x. The bottom is a difference of squares, and it factors to x plus 1 times x minus 1. And if you notice, the x minus 1, they cancel, leaving you with 2x plus 1 over x plus 1. And that's very similar to the very first problem that I did. It was linear over linear. The only difference is, yeah, it's linear over linear now, but there was a hole there at x equals 1. So what I'm going to do down here is I'm going to remind myself when I get finished with this problem that at x equals 1, there's a hole. And I'll worry about that last, okay? So now the x-intercepts, you set the numerator equal to 0. And when I say set the numerator, I mean set the numerator of the simplified version. So set 2x plus 1 equal to 0. So x equals negative 1/2. And then the y-intercept, they set all the x's equal to 0. So y equals, well, let's set 0. 2 times 0 plus 1 over 0 plus 1 turns out to be 1. So on my graph, I have two doorways again, y-intercept of 1, and I have a x-intercept of negative 1/2. So here's negative 1, so negative 1/2 is about right there. And again, it crosses. Okay, and like I said, most of these will cross to the other side. Most of them, they're going to set them up as if they're odd. So that one will cross. So here's my two doorways so far. Now, horizontal asymptote is the y equals, okay, it's the degrees are the same, so you divide the leading coefficient, so it's 2 divided by 1, which is 2. So y equals 2. In this case, there is a horizontal asymptote. Now, vertical asymptotes. Well, vertical asymptotes is set the denominator equal to 0, so x plus 1 equals 0 of the simplified version, so x equals negative 1. So there is a vertical asymptote there at negative 1. So it's kind of, it's kind of looking like the other ones now. Now, does it cross the horizontal asymptote? Well, now here's the simplified version. The simplified version is 2x plus 1 over x plus 1. That's linear over linear. If you remember the very first problem I did, I said if you ever have a linear over linear, it never is going to do that. So it's never going to cross the horizontal asymptote. But again, if you can't remember that, you can always set the function 2x plus 1 over x plus 1 equal to the horizontal asymptote. In this case, it is 2. And when you solve it, you get 2x plus 1 equal to 2 times x plus 1 in parentheses. So you get 2x plus 1 equal to 2x plus 2, and you get a statement that is not true. 1 equals 2, no way. So it does not cross the horizontal asymptote. Now, this one does not have an oblique asymptote because the degree on top and bottom are the same. So now we're ready to trace. So the graph actually will go from this doorway to this doorway, and then it seeks the horizontal and vertical asymptotes. So it goes up to there, and it goes down here. It ended negative, so it's going to start positive on the other side. It really has no choice, because if it started negative, they would have to cross the horizontal asymptote to get to the other asymptote here. You would have to cross the axis to get to the next asymptote, which it doesn't do. So that is almost the answer. Okay, if we didn't have holes, we'd be done. Okay, so holes is there's a hole at x equals positive 1. So what you have to do is come over to x equals 1 and go up to the graph and take a section of it out. You can use your eraser or whatever. Take a little bitty piece out, and that's a hole. Now this hole right here is treated very much like the vertical asymptote. They do the same thing. This hole, when somebody sees this one, they say, well, this number is not in the domain. When they see a vertical asymptote, they say x equals negative 1 is not in the domain. So neither one of them is in the domain, 1 or negative 1. Okay. The difference is, it's kind of like, some people see this and they say, well, it's in a vertical asymptote because this one's got a minus 1 in the denominator, x minus 1 in the denominator, and x plus 1. Well, you can also claim it has a x-intercept, but they cancel out. So basically, the two pieces, instead of going like this, like the other ones usually do, they kind of fuse together to one piece. And so it just kind of breaks it up in that. So that's the holes. How many of these holes do you see? You'll never see a hole unless you have a common factor. If there's a common factor, you're going to have a hole. How many of the problems in your homework you're going to see like that? Well, it depends on if you're my traditional class or my online class. The online classes are going to probably see quite a few of these. The traditional classes, not so much. It's just the way the software versus the book is designed. So, but anyway, so this is the graph, and this is the first one that we've had that had a hole in it. So remember, the hole exists when you have a common factor that cancels out, and you kind of wait to the very last to deal with that part of the problem. And so if there was a hole at x equals 1, so you do the rest of the I have a coat, and then when you get to the very end, go to that value and just put a little dot, a hole there, hollow point, whatever you're going to call it, and that completes the graph. So you got to understand, these are rational functions. Just like any other graphs, these graphs are representing the solution to this particular function. So, everybody's graph should be generically look the same. Okay, some people's bell might be a little lower than others. That's just semantics. If you want to get precise, and you have a lot of test points, and we're not so crazy about that. We're just going to try to put the vertical and the horizontal asymptotes in the right place, put the holes in the right place, get the graph's general shape in the right place, and we're good. Okay, so this concludes part 4. I have one more part I want to talk about that has an oblique asymptote, and I'm going to tell you the final exam will not have oblique asymptotes. Any of my written tests will not have oblique asymptotes. But unfortunately, the online students will see that on some of their quizzes and some of their homework because they built them in there. And so anyway, that concludes part 4. Got one more part to go.